Todos.
Good morning.
Bom dia a todos.
Yes, good morning. Good morning, everyone.
Vários participantes.
As far as I can see, we got many different participants, but I believe that many more will be joining us.
Pouco aqui, momentinho. Estou aqui com. Bom dia.
So good morning.
Bom dia, Kate Anne Souza.
Good morning to you, Kate Souza.
A gente gostaria só de lembrar que esse workshop vai ser gravado.
Let me just remind you that this workshop will be recorded according to our email, so that you can also use it at a later stage for future workshops or even for training sessions if you find it necessary. Good morning, Jonas. Felipe. All right, let me get started and start with my presentation. My name is Maria Gomes Val. Well, some of you already know me. I'm the coordinator of the project, Emurcibas. So I'm going to get started in Portuguese, just for the welcome words. And then I'll pass the floor to my colleagues. So this workshop is being translated, simultaneously translated into both Portuguese and English. All right, let's get started. Right, let me just share my screen with you now. Okay, this is the first online workshop. In fact, we intend to have many more to come. So I'll be as brief as possible in my presentation. I'll be moderating these workshop. I'm a researcher from Rheinval University here in Germany. And our speakers today, first we'll have Professor Dietrich Dar, also a professor at the Rheinval University from Agrobusiness. Then the workshop itself will be conducted by Dr. Rainer Nerger, and then Clara Larissa Risnega. They both from the Sustainable Consultancy for the carbon certification. And I believe that many other things and aspects will be mentioned. This is, in fact, a major company when it comes to the carbon certification standards, also here in Europe. So today we're going to have a very quick overview on the project, and then we'll move on to the presentation itself by our speakers. At the end, we will have a Q&A. Feel free to write your questions in a chat box throughout the workshop. We'll also be recording the questions, so you don't have to wait until the end to actually raise your questions. So feel free as we go along. Right, I hope you can see my slides. So this is our agenda today, and very briefly, just to say that Dr. Rainer Nerger and Clara Larissa will also present the different topics. And I will now pass the floor to Dietrich Dar.
Thank you very much, Maria, for welcoming us to this nice carbon certification workshop. Before we get into the topic of today, I actually wanted to take the opportunity to briefly give a broader context of what our project, the Ecosipas project, is actually working on, for you to understand more the overall objective and structure of the project, before we will then deep dive into the question of how can carbon certificates be generated from agroforestry or silvopastoral systems in our project region. So next slide, please. Yeah, so the overall problem that we try to address with our project is that we observe in the Cerrado region, as in other parts of Brazil, of course, as well, continuous land use changes. The Cerrado natural vegetation is under pressure by being converted into other forms of land use, agricultural areas mostly. And we know that the Cerrado is very important, not just for biodiversity or for the world's climate, because it is an immense stock of or sink of carbon. It is also very important for livelihood of the many people who actually live in the Cerrado region. And with our project, we try to contribute to developing sustainable or more sustainable alternative land uses. In particular, we look into the potential and performance of silvopastoral systems, which combine raising of livestock with production of native trees, many of which are actually the source of fruits which have potential for human nutrition and as a source of income for the producers. So this is what our project aims to do. We'd like to investigate the ecological and socioeconomic performance of these systems in order to generate knowledge that can help in making these systems more popular and more common in the Cerrado as one more sustainable alternative to the current land use transition that takes place in this region. Next slide, please. In particular, our project aims to address the objectives that have been listed on this slide. So we will start with an analysis of existing land uses and try to model the distribution of these sustainable pastoral silvopastoral systems in the region, depending on climate or socioeconomic development scenarios. We try to quantify the contribution of these silvopastoral systems in terms of biodiversity, carbon storage, soil and water conservation. We analyze their socioeconomic importance. We also look into factors that determine the adoption of these silvopastoral systems by local farmers and communities. We also look into value chains for the products that these systems can generate. For example, the non-timber forest products that can be produced out of the many fruits that grow on the trees in these systems. And we will finally also develop policy recommendations aiming at making these systems more popular and more easy for farmers to adopt. Next slide, please. We do this together with our Brazilian partners. We cooperate with the Genetic Resources and Biotechnology Center of Embrapa in Brasilia, colleagues from the University of Brasilia and from the University of Viçosa, and with a number of other non-academic partners, in particular with Emater, and a cooperative working with producers in the Cerrado region, Central do Cerrado. We also collaborate with international research partners from the University of Maryland. And on the German side, in addition to Rhein-Waal University, colleagues from the University of Freiburg and Sustainable Climate Consulting, who will today lead us through the main part of the question of how can carbon certificates be generated and also measured from such systems. Next slide, please. We work in two areas in the Cerrado region. One is the Rio Pardo River Basin, and the other one, the Rio Urucuia Basin. I don't want to go into the details here. We have just started data collection in these areas and will be working there more intensively over the next month. Next slide, please. And of the many work packages, I would like to focus on one work package 5 in particular, because this is where the work on carbon certification is located. In addition to our work on value chains with the objective of helping local producers to generate income or additional income from using the non-timber forest products or other products that are produced in these silvopastoral systems, quantifying the carbon stored in these systems and generating carbon certificates is also one way of potentially increasing income of producers, because carbon finance can be an additional income stream to managers and land users of these systems. This is what we aim to do with our workshop today. Next slide, please. In particular, in this work, over the next 12 to 18 months, we will be developing, colleagues from Sustainable Climate Consulting will be helping to develop a feasibility study and a business case, which will allow us to assess the feasibility of generating carbon finance income for local producers and land managers of these silvopastoral systems in the Cerrado region. And today we kick this work off with this general workshop on the principles and potentials of the carbon financing in agroforestry. Next slide, please. Let me quickly introduce you to the concept of agroforestry systems, silvopastoral systems, the one that we study in the Cerrado region being one of them. They refer to land use options in which agricultural cropping or livestock keeping or both are combined with growing trees on the same unit of land. This has a number of environmental benefits and socioeconomic benefits because these systems are more diverse, they are more stable to climate change impact, for example. They can generate additional income from products which are not major commodities, for example, and therefore may be less prone to price fluctuations and these cycles in the agricultural markets. However, they also face a number of problems. One relates, for example, to lack of knowledge of land users for these systems and a number of research gaps. And we would like to contribute with our project to addressing some of these. Next slide, please. Just for you to picture how these systems could look like in the Cerrado region, this is an existing silvopastoral system involving native trees in the Cerrado region, and much of our study area actually looks like that. Next slide, please. And from these trees growing on these animal pastures, local communities can collect wild fruits, for example, the baru fruits, which are potentially useful as a food product, not only for animals as animal fodder, but also for humans, because the nuts inside these baru fruits can be commercialized, and actually they are a high value product which can also be exported to international markets. Next slide, please. I mentioned already challenges for implementing these systems, lack of knowledge, lack of know-how, lack of research on these questions. And one additional factor, and our project aims to address this in particular, is the relatively lower financial profitability of agroforestry systems when comparing them to intensive agricultural systems, and generating additional income streams either from commercializing these non-timber forest products or from carbon finance is actually one way of helping to make agroforestry systems and silvopastoral systems in the Cerrado in particular more attractive to landowners. This is the overall context of our project. Next slide, please. And I think we can quickly go over this slide. I would like to end at this point, and we look forward to an interesting presentation by our colleagues from Sustainable Climate Consulting and to the many questions that may come from our audience. Thank you very much, and I pass the floor back to Maria.
Muito obrigada, professor Dietrich Dar.
Yes, thank you very much, Professor Dar.
Eu gostaria só, eu não sei se todo mundo aqui já utiliza o Zoom com...
I don't know if you're familiar with the Zoom platform with the simultaneous interpretation. Well, for me, it's the first time that I'm using these with simultaneous interpretation. So just to let you know that at the very bottom, you've got the little globe where you can actually choose the either Portuguese or English. So just click on the language you want to listen to. All right. So that was just a quick reminder. Okay, I'll now pass the floor to our speakers from Sustainable Consultancy.
Thank you.
You're welcome. Yes, I would maybe just ask you to bring just to bring it to yes.
Thank you. Welcome to our presentation on carbon sequestration and certification agroforestry systems. My name is Dr. Rainer Nerge. I work together with my colleague Clara Vriesnecker at Sustainable AG. We are a consultancy for sustainable agriculture and agroforestry, and also for development of carbon-related projects. We have a short agenda. We will introduce you to our company and to the project, then introduce you to basics of agroforestry systems. Afterwards, to carbon calculation methods, carbon standard certifications, and ecosystem services, and how they are covered by different carbon standards. And as a last point, we will have a question and answers session. Just again to our staff. That's me. I work mostly here in the upper part. I work mostly for nature-based solution projects on soil, carbon, regenerative agriculture, and agroforestry, while my colleague Larissa Vriesnecker does the same. And additionally, she also works a lot in carbon footprinting projects and development of climate strategies within agricultural supply chains. The next slide is to introduce our quickly our company. We are here in the agriculture and agroforestry team. We are approximately 20 specialists in agriculture and forestry, soil science, horticulture, environmental business administration, and so on. And we mostly work with nature-based solution projects, carbon accounting, tool development for primary data collection, soil fertility, organic and conventional farming advice, but also communication, change management, and moderation techniques. And now I hand over to my colleague Clara, who will introduce you into the project and into agroforestry systems. Thanks.
Yeah, thank you, Rainer. And a warm welcome from my side as well to all of you. As Rainer said, I will now give you first an overall introduction to our joint project. And yeah, you can get to the next slide, please. Perfect. Here you can see the project overview, which is divided into two main parts. It's the part one, which we talk about today, but also in 2024, there will be a second part of the project where a feasibility study on the CO2 certification as an ecosystem service in silvopastoral systems in Brazil will be done. So, but today the focus is on firstly giving you an overview of standards for carbon sequestration in agroforestry system to form a base for that second part. Next slide, please. Before I will deep dive into the aspects of today's meeting, I will give you a short overview about what does a feasibility study include overall, that you know what are the next steps within the next year, for example. First, we will start with a pre-assessment of the goals and measures and their potential of CO2 sequestration in agroforestry systems. Secondly, we will look into business cases and carbon project options, which are, for example, carbon credits, in-settings, but also contribution claims. After that, there will be a cost analysis and a cost-benefit ratio. So analyzing how much does a project like this costs and what are the benefits actually when carbons are sold. Yes. So next, there will be an APL feasibility, which means it will be assessed if the additionality, permanence, and leakage of the systems. So permanence does, for example, mean, is it possible to really sequester carbon for a long period of time without losing the carbon again, which would be the leakage? And is this actually additional to current land use practices, for example? Another aspect is the technical feasibility, which will focus mostly on the material. Is there enough material available for the project, or also are there enough labor or monitoring techniques? After that, we will look at applicable risks. These risks involve, for example, economic, social, and ecological risks, which does not only mean that the risks for the project, but also the risk that maybe the project gives to the surrounding area or project area. So if there are differences from the prior land management practice. No, it's not the last point, but yeah, after that, we will do a feasible implementation method. So this refers to actually the first point of the road, the goals, measures, and their potential. And we will look into if these goals and measures we looked at are really feasible to implement in the end for the project area. And yet now, last but not least, the eligibility of the project options. Here, this refers to the second step of the roadmap, the business cases. So we will look here into if the project options, which project option is actually the best case for the surrounding area or the project type. Next slide, please. Here, I would want to give you an overview of the overall goals of the project, which is the part of the project which is done with Sustainable AG, the feasibility study. So the overall goal is to improve the economic performance of the agroforestry systems, and also creating incentives for further promoting of agroforestry systems in this area. The reduction of soil erosion, soil degradation, and loss of forest area, and creation of additional business models and local value creation, as well as additional income for local population. Thanks. Now to focus on that part, which is the basis of today's workshop. It's the project goal of part one. It's the basis for the assessment of the general suitability of different standards and methods for certification of carbon sequestration in agroforestry system. So the basis the basis information that is needed to go the next steps. Next slide, please. So we now talked about the components and goals of the project. And with that knowledge, we want to deep dive into the introduction of agroforestry systems, recognized as effective carbon sinks with crucial role in sustainable land management. We already heard some of the information from Professor Dar today, but we will deep dive a little bit deeper. Next slide, please. Thanks. So firstly, we want to talk about the main characteristics of agroforestry systems. These systems intentionally combine the cultivation of woody perennials with agricultural crops and/or animals, like mentioned for the silvopastoral systems. And this is done on the same land unit. The deliberate integration aims to optimize the interactions between these different components to achieve a variety of ecological, economic, and social benefits. We already heard of some of the benefits, but just to remind you a bit of the benefits, it's, for example, the efficient recycling of nutrients, and that is causing and minimizing nutrient leaching. Then the improvement of the microclimate, for example, which is lowering the soil temperature, and the improvement of the overall soil structure, which are known as ecological benefits. And on the social and economic side is definitely to say that the diversification of income forms a more secure livelihood for farmers implementing agriculture. And already mentioned a few, there are also negative interactions of the species that shouldn't be neglected. It's, for example, the competition of sunlight leading to shading effects, but also the competition of maybe water and nutrients. However, important to highlight is that these limitations are not roadblocks. So they can be decreased by effectively combining suitable species, for example, and carefully choosing the agroforestry system in place. So it's kind of more like understanding and optimizing the structure of agroforestry systems to decrease the negative impacts and achieving the desired outcome in the end. Next slide, please. Yeah. So here we see two relevant agroforestry systems we find noteworthy to name for the area of Brazil. The first one is the perennial crop-based system, for example, growing cacao. And here it's that, for example, shade-tolerant species are combined with, like cacao and coffee, are combined with other woody perennial crops. And on the other side, the already mentioned silvopastoral system, which is combining woody species with grassland, for example, where often animals are grazed. So these practices exhibit variation in structure based on specific goals, local conditions, and land users' preferences in the end. Next slide, please. Now I want to shift the focus more to the carbon sequestration potential of agroforestry systems. And here I want to start with the classification according to IPCC, where agroforestry systems fall under perennial crops, which are plants that grow for more than one vegetation period. The benefit of agroforestry extend way beyond the traditional monocultures, where especially concerning carbon sequestration and also climate change mitigation, that was also mentioned beforehand. By incorporating trees into agricultural landscapes, they can sequester carbon in a higher amount than without these additional woody biomass. this happens not only in the biomass of the tree, but also in the soil. So there will be a carbon increase from the additional trees plus within the soil. But the amount of carbon sequestration depends on various factors. For example, this plant species chosen for the agroforestry system, but also management practices in place. Worth noting is that agroforestry systems not only tackling climate issues, but also biodiversity issues, which is another huge issue in common times. So, for example, through habitat diversification or improved connectivity of the different habitats, but also it is oftentimes less pest control needed for these systems. So next to the carbon ecosystems, the carbon, there are other ecosystem services tackled by agroforestry systems. Next slide, please. So now we explored agroforestry a bit. We've learned that agricultural systems are a mix of perennial crops with other agricultural systems, and it is creating a system full of benefits, or can be full of benefits in the end. It can not only sequester carbon, but it can also increase the biodiversity and also having an effect on climate mitigation. For carbon sequestration, there's a possibility of a return on investments via selling carbon credits. But this is actually, that it depends on how much carbon is actually sequestered, and this amount needs to be accounted for. So this is part of this chapter, how to account for the carbon increase in the systems within soil, but also within biomass. And we will focus on the main approaches to give you a good overview of the approaches and not deep dive too much, but yeah, you will see in this next slide. So thanks. Starting with the accounting methods within above ground biomass, there are 4 different approaches I want to highlight. First is the classic sampling and measurement campaigns. So it means conducting annual measurements of the carbon of above ground biomass using, for example, tape measures as seen in the picture in the left upper corner. And measuring the tree's diameters. With the tree's diameters, a relationship can be formed between the diameter and the total biomass or carbon stored within the tree. So these relationships are mostly formed by allometric equation, and allometric equations oftentimes also include the relationship to the below ground biomass. So the whole biomass in the tree is covered above and below ground with measuring the diameter. Another parameter could be, for example, the height, depends on the allometric equation. The second approach we want to highlight is the modeling approach. Here, biological processes for plant growth and carbon accumulation is simulated, considering different factors, for example, the photosynthesis or respiration. Here to name, for example, the IPCC model for hedges in the second picture of the left picture. Yeah, exactly. So thirdly, I want to highlight remote sensing and machine learning. These are advanced measurement techniques. And for example, for remote sensing, we have the normalized difference vegetation index we can use to implement into models to have a higher model accuracy. And on the side of machine learning algorithms, they can identify complex patterns within large data sets, and in the end, improving accuracy of biomass prediction when trained with relevant data inputs. The last point of the slide is the global digital online maps. We can use online maps from like the platform Global Forest Watch. This makes it very easy to estimate carbon in plants and gives us a worldwide view and help us to understand how much carbon is stored from a big scale perspective. Worth noting is that all models needs to be calibrated with primary data, and also the results needs to be verified after a certain time. So although modeling approaches can be used or calculation approaches, the basis must be sampling. Next slide, please. Yeah, thank you. So same procedure as in the slide before, we have the introduction of soil methods. Again, we want to highlight 4 of them. We're starting again with the classic sampling and measuring campaigns. So these are traditional methods for soil samplings, meaning that samples are collected using, for example, a drill stem, and then the soil goes to a lab where the carbon content then is analyzed, often through techniques like, for example, the dry combustion method. While this method is very thorough and reliable, it can be very labor intensive and costly. So there is a new approach available, and it's the new spectroscopy soil scanner approaches, using soil scanners like handheld near-infrared and or mid-infrared scanners. You can see a picture here again. So using these scanners significantly reduces the effort compared to the methods mentioned above. Employing these spectral information to precisely determine soil carbon content. So the scanner allows directly on-field measurements actually of the carbon content, which eliminates the necessity of expensive sampling from the method above. So this not only saves time, but also proves cost effectiveness. Third is the process modeling we want to mention. These are models based on processes which offer a deeper insight into dynamics of the soil. These approaches consider various soil processes, aiding to better understand the carbon cycling within the soil and modeling the carbon increase. Last but not least, we have the remote sensing and global online maps. They allow for a comprehensive view of soil carbon on a larger scale again, by integrating remote sensing data and global maps. Valuable insights into the distribution and quantify of soil carbon worldwide is gained. Here again, like the methods mentioned beforehand, the models and calculation needs to be calibrated and verified with primary data. Next slide. Yeah. So within this project, we started a detailed research campaign on the methods available for carbon, for the calculation of carbon. So the methods to calculate the increase of carbon within, for example, agroforestry systems, within soil and biomass. And we present that in an output table within filter function. We included not only like classic, but also new approaches like the handheld near scanner for determining the carbon in soil. We also talked about some approaches, but in this table we detail these specific models. So not only the overview approaches like remote sensing are included, but also deeper knowledge on specific different tools and methods. Later in the presentation, you will get a glimpse of the outcome in the Excel table. Next slide, please. Central aspects of this table include, for example, the method, like is it remote sensing based or is it measurement based or model based, for example, including a description of the model, the method in detail. then there will be a differentiation between if the usage is commonly, rarely, or experimental. For example, if it's a very novel approach, it is probably experimental, but then there are approaches used for several decades, so they are commonly used already. Then included is the area coverage. So does it cover, for example, global, like for example, with remote sensing, or only local conditions, like with the measurement approach? Is the accuracy high to low, or is the cost high to low for the different approaches? And is it possible to use the approach for the applicable standards in the end? And we listed some advantages and disadvantages. Next slide, please. So, but how can the results in the end be used? This table can be used like sort of a decision tree in the end. The most appropriate and relevant calculation methods for carbon removals can be identified by filtering through different aspects you need to include, for example. It can be assessed which methods are allowed at which carbon standard, and also possible to do a quick research on available methods. Next slide, please. So now I will hand over again back to Rainer, my colleague, and he will talk about the carbon standard certifications.
Thank you, Clara, for this interesting presentation. I will continue with the topic about, or the next element of our work we have done until now, which is about carbon standard certifications or certifications under the carbon standards. So now I have to do the slides here. So, first of all, the question, what are carbon standards or carbon certification bodies, perhaps also named sometimes? So first of all, one can generate or one can develop carbon project and generate carbon credits under these carbon standards. So carbon standards are certification bodies, mostly non-profit organizations, and they verify and certify the achieved carbon sequestration, but also emission reduction. In our case, rather carbon sequestration, where the result is then the carbon credits. They use often rigorous criteria to assure a positive environmental impact and that the carbon sequestration is real. And so they function as also as quality assurance bodies. Additionally, some of them act as market places where carbon credits can be purchased by by companies or institutions to do a carbon offset. On the next slide, we have some of these carbon standards listed, which might be relevant for our case. This is like a global overview. It does not contain specific national Brazil carbon standards, but we also had them investigated. I will come to that later. So on the left side of the slide, here are some larger carbon standards listed, like you might have heard of the gold standard foundation is the carbon standard. It's called gold standard for the global goals. Then we have the verified carbon standard, which is operated under Verra. The organization is Verra. And we have also, for example, here the American Carbon Registry, which might be relevant, also quite large. And then switching to the center of the slide, there are so-called additional standards. What is that? These are standards which do not certify directly carbon sequestration, but the positive impacts on things like environment, social issues, water storage, biodiversity. So while one can add them to one of the carbon standards, for example, here this verified carbon standard on the left, you certify the carbon certification with that, but if you want to prove or to certify that the project has a positive impact on the environment, then you can also use this such an add-on standard here, like this climate, community, and biodiversity standards, also developed by Vera, or this one here. While for other standards like this gold standard, they have already such non-carbon benefit certifications also directly included in the main standard. And on the right hand, there is a small list of smaller carbon standards, which are not so well known, but are quite relevant as well sometimes. This is, for example, Plan Vivo and Region Network, or the Acorn standard from the Dutch Rabobank. All of them, they have a focus on smallholder farmers, and so they are perhaps not that costly, but more appropriate often for smallholder farmers. So the costs here for the standards, here's on the lower part of the slide, you see here an arrow, while often the larger carbon standards are associated with higher costs than the smaller carbon standards are a bit less costly usually when developing a carbon project under such a standard. So so we had them those standards and also others researched, and our research results we documented in an Excel output table, a quite large table, which includes several carbon standards. Actually, we had approximately over 40 carbon standards researched and checked them also for relevance for our case, yeah, for agroforestry option in Cerrado region, Brazil. And approximately 13 to 15 of those standards we evaluated as relevant. I will show that later in an Excel, a quick look at an Excel table. And of those 13 to 15 standards, we evaluated them to the most relevant certification aspects. So the aspects which are then relevant for carbon certification. And the aim is of all this research in this list is identifying the most suitable carbon standard for your purpose. And so this resulted in an output table with filter function. Here, amongst others, we checked for these aspects, type and focus of standards. So do they have a focus on agroforestry, on fruit trees, on silver pasture, on smallholder farmers, yes or no? What is the reputability of the standard? Is it rather high or low? The costs also, we had a look on the costs. Are they rather high or low in comparison to other carbon standards? And then furthermore, the crediting period. This is the time period a carbon project is supposed to last. Yes, different carbon standards have different requirements on that. So it can be 10 years, it can be 30 years, it can be 100 years. So this is documented. As well, the focus of a carbon standard on ecosystem services, requirements after such a carbon project. So what happens after 10, 30 or 50 years? Are there still further requirements, or can you just cut down a forest or trees? Then very central aspects as additionality, leakage, and monitoring. So what monitoring is required? What are the requirements for the so-called leakage? So this means just that a carbon project should not have a positive impact on the project area, but must not have a negative impact on the surrounding area. And additionality is the requirement that all these measures which lead to carbon sequestration should be additional and not mandatory by law or done by other reasons already. So and the need of a third-party certification body, which is an extra body certifying, again, going to the area, to the project area, checking all what has been done, that measuring trees, checking fertilizer bills, etc. All that we included here. So, and yeah, again, we use the results for the identification of a most suitable carbon standard. This work, and also what my colleague Clara already said, is a pre-step for the next project phase, the feasibility study, which will start next year. And this feasibility study will give a more thorough introduction into this into those carbon standards, especially under the specific project circumstances. So whether is a plant, what are the options for the carbon project, and is it really feasible? Is it too costly or not? Will it bring sufficient carbon removals or not? But does it have potential risks and barriers and everything? But this was what my colleague already said before. Then we encountered some specific questions on carbon standard certifications. For example, who's the owner of carbon credits? Yeah, if you generate carbon credits with the carbon project, then who's the owner of that? And this ownership depends on often on a contractual agreement between the carbon project partners. For example, between smallholder farmers and the institution administrating the carbon project. So some carbon standards, especially, as I said, the smaller carbon standards like Plan Vivo or Acorn, they even require carbon rights, so ownership of credits for smallholder farmers. Then the next slide. What about the tradability of carbon credits, or a similar term is here CO2 certificates? Where are they traded? And we answered that the trade location depends on the carbon standards and also on national regulations, of course, for example, on direct Brazil regulations. Some carbon standards, like the gold standard or Plant Vivo, they offer own marketplaces where one can trade those carbon credits. We linked them here. And one can also trade them directly with private marketplaces, for example, those ones listed here, or trade directly with an interested party. But always, of course, one is supposed to consider national regulations. So a country might have restriction for carbon credits and carbon trade. So this can be amongst others, this can be a carbon tax. So this is a thing which we will touch in the next phase in the feasibility study. So what, for example, specific Brazil regulations for that we will then check and say, okay, this is possible and this not. The last element of our research is the coverage of ecosystem services by those carbon standards. So is a carbon certification also able to cover specific ecosystem services? And first, the question arose, what are ecosystem services? We identified the following supportive ones here. Nutrient cycling, for example, water cycles, soil formation, primary production, biodiversity. So all those services which also come when one plants trees, but also provisioning ecosystem services like food, fresh water, wood and fiber, regulating ones like climate regulation, erosion prevention, and so on, and even cultural ecosystem services. And on this slide, we see here the also a good compilation of ecosystem services. These are the United Nations Sustainable Development Goals, the SDGs. These are global goals for our entire planet. 17 goals to transform our world, announced by the United Nations, and among them are no poverty, zero hunger, good health and well-being, quality education, and so on, and also ecological global goals like climate action here on the number 13, life below water, life on land, and so on. And many carbon projects cover, are supposed, at least under some standards, cover those three here: responsible consumption and production, climate action, life on land, and it is recommended to cover more goals. There are then specific specific requirements how to cover such a goal. One needs to fulfill specific indicators, and then such a goal would be covered for that part. And so the research results were again detailed research table, an Excel table, an output table, where we listed carbon standards and their coverage of some of ecosystem services. We used a level-based evaluation, 1 to 3, where we had a look on, is this ecosystem services, or short here ESS, is this covered within the standard in general? And then a bit more into detail going, does this ecosystem have to be also assessed and quantified? So is this necessary? And the level 3 is, do I have to cover this ecosystems to assess this ecosystem service once, or do I have it also to monitor over the entire project period? So those three levels, where level 3 is best, of course, this evaluation scheme we used here. And we identified impact on as ecosystem services on focus ecosystem services. We identified sustainable development goals by the UN, water quality and supply, then prevention of erosion through wind and water, species protection, soil health, and derived products. So, and this output table is supposed to give an overview over all that related to ecosystem services, and shows its uses also to have a quick look about specific requirements for these ecosystem services using a filter function, and so one can use it to identify the most suitable relevant carbon standards to cover such ecosystem services. So it's always important, a good impact on ecosystem services, thus on agroecosystems, on biodiversity and other aspects, is always very important, and not just, of course, not just the CO2 achievement. Then I would like to quickly show you the Excel table results. It's not a video demonstration as it says here, but it's a quick look on an Excel table. How does it look like? And I hope you can see this Excel table. Otherwise, please interrupt me. So we will show you now here, as said, my colleague Clara spoke about the carbon methods, so methods for carbon to determine carbon sequestration, but then also here for carbon standard certification and ecosystem services. We have them here in a central Excel table. It's just a quick look. You don't have to read all of that. I would just like to introduce it to you, how it more or less how it works. So you see here a lot of columns and lines, and all those lines are specific single methods and single approaches for above ground biomass determination, so determination of carbon in biomass. And then here below also for soil to determine carbon in soil, because when one grow trees or implement projects with silvopasture, then of course you have carbon stored in trees, but also more carbon stored in the soil, because all the leaves, the twigs, and small branches from the tree and the root exudates, they increase carbon in the soil as well. So we had here approximately researched 60 single methods, and those range here from classical methods, as my colleague Clara already said. So measurement based methods like measure diameter at breast height at a tree, but then also modeling model-based approaches, for example, with the IPCC model, and remote sensing approaches like hyperspectral LIDAR data and so on, Sentinel, Landsat data, all that can be used, hybrid options and so on. And we describe them here, documented advantages and disadvantages, and also added the source and further reading. So, and we did this for both for biomass and soil methods, and covered classical and recent approaches. Yeah, for example, very recent is the remote sensing for soil carbon. This is a quite new method, which is allowed, for example, currently under the VERA or Verified Carbon Standard. This can then be seen here in this table. Then I switch here to the next sheet here. Now I'm not with carbon methods, but with carbon standards. So we have here, I spoke about that. We had here, we spoke about gold standard, verified carbon standard, and here this is the central table with all the research results. So it can be used to find standards which have focus in agroforestry trees in silvopasture. Yes or no? So I just open here the where is it here? This drop-down menu, and then I can choose the preferred option, and each standard is here evaluated due to all these aspects I spoke before. And you will get these tables in not just in English language, but also in Portuguese language, of course. And it's supposed to be quite useful in terms of selecting an appropriate carbon standard. So which is the best standard, yeah, which brings the best results by lowest cost and most appropriate focus. This is the purpose of it. And here's the last element, the ecosystem services coverage. So again, here the carbon standards in the lines, and we show here how well they cover the specific ecosystem services here. Sustainable development goes in these columns, and then here in those columns, water quality and supply, and then the others, prevention of erosion, species protection, and here are the level-based evaluation I spoke about. So one can also filter here the the carbon standards are by quality level. So you will this will be available then also in Portuguese language, and we hope it will be useful. It can be adapted, of course, and that is my that was the presentation, and we now go to questions and answers. So please don't hesitate to raise a question, and thank you.
Olá, bom, vou voltar aqui pouco.
Okay, I'm going to go back a little bit to moderate this session, the last part of our seminar. I have a question here from Mr. Thomas Yoga. I'm going to ask the question in English because the question is written in English, okay? So I believe that this question might be for you, Rainer, or for Dietrich. Okay, it's here on the chat. I shall read the question in English now.
Sorry. É só pouco difícil ler a pergunta e escutar a minha
It's not so easy to read the question and listen to myself speaking.
Agroforestry systems.
I did not yet understand the
Rainer,
question.
the question is on the chat. I think you can.
Ah, yeah, okay. Okay, on the chat. Okay.
Agroforest systems. He said there are options such as the tree strata forage system.
Is it this one here? I have something here on my screen.
Yeah, I think I can come in and try to answer this question. So the question is whether we look into some more innovative agroforestry systems. The example that is listed here is a system that was developed first in Indonesia, and apparently it involves the cropping of different layers, including also fodder for animals. And my answer to this question is what we do is slightly different. We look basically into the gradient of entirely natural cerrado vegetation on one end of the extreme, and on the other end of the gradient, the intensive pasture systems, which typically involve cultivation of bracharia grasses and sometimes also eucalyptus trees in rows, and then a number of intermediate steps in between with more or less dense cerrado vegetation elements, these native trees in particular. The reason why we've focused on these existing systems in the region is that a 3 years project is very short for introducing an entirely new technology into a region, and for setting it up and taking the measures that we need in order to be convinced that this is a feasible system in the region. Yeah? So this is explicitly not our approach, but we are absolutely aware of the fact that a lot of innovations exist that aim at improving land use practices also in the semi-arid environments of Brazil. And for sure, there's a lot to learn from other projects that have been carried out in the region or elsewhere. So thank you for this question.
And I see another a comment here from Miss Thomas Hilger from University of Hohenheim. That you worked already with the Van Ulcas model in Brazil, and that you started exploring the model's potential for Macauba palms based agroforestry systems. This is very interesting. As you remember from Clara's slide, we also had the Van Ulcas model identified as a an interesting approach for modeling, and we would like to exchange information if you want. This would be interesting to see what you have found, or you can also send us a report or something like that if you have something available. Otherwise, we can also talk about. And then I see a question here. Will you share the spreadsheet at the end of the workshop, please? Thank you. Yes, yes, we will share, not directly after the workshop, because we first needed to translate it into Portuguese, a language, but then you will receive the spreadsheet in English and Portuguese. Language is supposed to be finalized, correct me if I'm wrong, Maria, at the end, still this year?
Exato.
or perhaps start of next year.
Exato.
Yeah. Still this year or start of next year, but very soon. Very soon. Yes, you will have it available, then we'll send it to you.
Obrigado, Raina. Ainda temos duas perguntas aqui em português que eu vou traduzir.
Okay, we've got two questions here in Portuguese, which I'm going to translate into English. A question from Jonas,
From UFR Bio.
UFRBO, Centro-Oeste.
Hi, I have a question about how would you do the future modeling of agroforest systems with the climate change, or based on future climate changes? Just can you give me or provide me, please, a very general view on it?
Sorry, I had problems to understand the question. It was due to the acoustic quality.
Okay, I will.
But I understood how
again repeat. He says, how do you see the future models of carbon sequestration inside agropastoral systems based on the future climate change? So can you just give me a general view?
You mean directly the modeling approaches of these models? We have
Yes.
we had shown, yeah, they are of course research results, and they are still being improved. And so, for example, IPCC models, they are improved on a continuous basis, so that they will also continuously cover the more scientific results and knowledge from current studies, which then involves also climate change related results. So in theory, they should be feasible or able to do a more adequate modeling in the future about climate change impacts. Yes, we think, yeah, we have trust in that, but we are no modeling experts in this regards.
Sorry. So we have here another question, also in Portuguese, that I'm going to translate. I guess this question then will go to me and to Professor Dietrich Stahl. What are the areas selected to the project, in case you already have selected them? Would you answer that, Dietrich, or?
Sure, I'm very happy. I think I had a quick word on this in the presentation at the beginning. We have selected two study areas, two basins or watersheds, basically in the Cerrado region. One is the Rio Pardo de Minas basin, and the other one, the Rio Urucuya watershed. And we have just started data collection in one of these, and will move into the second site then at the beginning of the new year.
Thanks very much, Trista. Then I ask you, now we don't have any more written questions here. Maybe, I don't know, if you would like then to make your question here. Maybe we'll open here shortly, as we still have some time for people who would like to speak their questions here.
Yeah, perhaps just to add to what we have already said, we look into very positively into the next year with the feasibility study aspects, which will show us concrete results, concrete risks, barriers, opportunities, and costs of our relevant project option. This will be very interesting. We will also collect a specific data, and yes, we hope then as the result of the feasibility study will lead to clear recommendations, or it will lead to clear recommendation what is then possible, what kind of carbon project. And my colleague Clara Vriesnecker is an expert in that and will lead this feasibility study. And if you have any questions, any regards to what will happen next year, then you can also just ask now. Just shout, please.
I have seen here that Antonio Carneiro has a question here in the chat. I'm translating the question. He said, is this project going to be extended to other regions as well? And I don't know if we would love to, of course. Then I maybe pass the question here to Professor Dietrich. We also have here connected Professor Carlos Torres, which is also part of the project in Brazil, one of our partners. So I would maybe pass the word to Professor Carlos, that he... Right.
Eu vou falar em português porque a pergunta foi feita.
Carlos, sorry, we cannot hear you.
No?
Oh, I can hear you.
Yeah? Ok. Maria, você não me escuta?
Maria?
Sorry, I'm not sure if I'm the only one who cannot hear.
Ok. Vou responder. Dietrich, could you hear me?
I can hear you.
Ok.
Okay, just to confirm that everybody can hear, Carlos.
Em princípio, não, porque esse projeto ele foi feito em duas áreas específicas, né?
Now, this project was in fact conducted when there were already some practical works being carried out by one of our partners. And these different domains or regions were actually selected because of the previous work. Now, in terms of financial resources, this is what Dietrich talked about the different packages that we actually have. But now time has come to see the adoption before implementing. Basically, we need to understand the reasons why people are using this or that particular system. And we need to see the kind of differences among regions, etc. But when it comes to resources, we are not going to implement them. We actually do not have time for these because our time is up to 2025. So it's a very short period of time for us to actually assess, etc. So we need to assess what they've got, why it is done so, why these selection of species, etc. Maybe in the future we'll be able to come up with a different project to try to analyze these questions about the management best practices. But for this particular project, we do not have the right resources. I don't know if Dietrich would like to elaborate a bit more on these, so feel free.
Yeah, thank you, Carlos. I think you've already nailed the question. Maybe just one thought that I would like to add. The workshop that we have set up today, I think, is also an instrument for us to reach out to areas beyond the immediate research sites. We would like to spread our results and the work that we are doing and knowledge that will be generated, of course, to other regions in the country, enabling other stakeholders in their respective areas to benefit from the work that we do. And by this, we may be able to multiply the benefits that our project can generate. This is unfortunately due to the resource constraints that we face with this research project. But as Carlos said, of course, we are open to developing further research ideas that may take us then into other areas of the country as well. Thank you.
Muito obrigada a pergunta, Antônio. Antônio Carneiro, seu Antônio
Thank
Carneiro.
you very much for your question, Antonio Carneiro.
Então, agora eu pergunto mais uma vez se ainda existe mais uma questão aqui.
So again, is there any other questions from our participants in the room?
Gostaria de dizer aos participantes que ao final do workshop,
Let me just remind you that at the end of the workshop,
disseminar aqui os documentos que tivemos para vocês.
we are going to provide you with the documents
Entendível, espero, né, para vocês.
so translated also, and I'm going to send these documents via email
A inscrição online ou então aqueles que também
for those that registered online, or even if you send your registration to Carlos, so send directly to Professor Carlos. So those email addresses that I've got, then I'll be able to send you the documents.
Muito obrigada.
Thank you.
Então, retorno aqui a palavra ao professor Dietrich.
So back now to Professor Dietrich.
Por favor, Dietrich, a palavra é com você.
The floor is yours.
Okay, so then it's up on me to finally close this workshop. I thank you all for your participation. I thank the presenters for their time and wisdom you have shared with us. I thank you for your interesting questions, and I look forward to the next year in which we will make further important steps and generate results that we will share at a later stage then with all of you. Thank you very much and have a nice afternoon.
Thank you. Thank you for your interest.